Hello. Go ahead and turn in your workbook to chapter 8, and we're going to turn to the page that says 8.3 Special Right Triangles, Day 1 in-class practice. Okay, our in-class today is virtually at home due to the snow, but we can still go ahead and review our 45, 45, 90-degree triangles and our 30, 60, 90-degree triangles. Okay, we're going to take today and we're going to review our special right triangles and then look at some word problems that also involve special right triangles as well as the Pythagorean theorem. Okay, so the majority of the work today will be done out of the workbook. Now for day 1 in-class practice, we're just reviewing, given a special triangle, can we find missing sides? So it says for numbers 1 through 15, find all missing sides. In problem number 1, I have an isosceles right triangle, which means this represents a 45, 45, 90-degree triangle. Now, I put up at the top my formulas for each of the triangles, my shortcuts. So for a 45, 45, 90, what I know is that my leg times radical 2 is equal to the hypotenuse. Okay. Now, in this picture, I'm given a side length of 4. This represents one of my legs. Okay, and since it's isosceles, the other leg is also 4. So I'm going to go ahead and fill in over to the side. Here's my leg of length 4. And I'm going to plug the leg into the formula to find the hypotenuse. So I'm going to replace the leg with 4. So 4 times radical 2 is equal to the hypotenuse. Okay, and this is already in simplest form. So the length of my hypotenuse is 4 square root 2. Next, I'd like to look at problem number 3. Again, this is an isosceles right triangle because I have 2 congruent sides, which means my 2 base angles, which also have to be congruent, are both 45 degrees. So once again, I have a 45, 45, 90-degree special triangle. So I know that the leg times radical 2 is equal to the hypotenuse. In this problem, I'm given the hypotenuse, and I need to find the lengths of the legs. So in my formula, I'm going to replace the hypotenuse with 12 units. So I have leg times radical 2 is equal to 12. To find the length of the leg, I solve the equation. The opposite of multiplying is to divide. So I'm going to divide both sides by the square root of 2. On the left side, the leg remains, and this is equal to 12 divided by square root of 2. Now, I cannot keep a square root in the denominator. I have to rationalize, and I do that by multiplying the numerator and the denominator by the square root of 2, which is the denominator. We multiply straight across. 12 times radical 2 is 12 radical 2. I can smush those together when I have one inside the radical and one outside the radical. In my denominator, the square root of 2 times the square root of 2 is the square root of 4. When I have 2 numbers inside of a radical, I can multiply those together. Now, the square root of 4 is 2. So this is equal to 12 radical 2. Square root of 4 is 2. And notice outside of the square root, I have 12 divided by 2, which is 6. I can complete that operation, and I have 6 radical 2 remain. So the length of my leg is equal to 6 radical 2. So in my picture, my legs are congruent, and both of those are 6 radical 2. Okay, next I'm going to move on to problem number 4. Okay, in problem number 4, I have a 30, 60, 90-degree right triangle. Okay, in a 30, 60, 90-degree triangle, I have a shorter leg, a longer leg, and the hypotenuse. Okay, if this is my 60-degree angle, then this angle up here is my 30-degree angle. The side opposite my 30-degree angle is my short leg. The side opposite the 60-degree angle is my longer leg. And the longest side, the side opposite the right angle, is always the hypotenuse. Okay, in a 30, 60, and 90 degree triangle, I know the short leg times radical 3 is equal to the long leg. And I know that 2 times my short leg is equal to the hypotenuse. I'm going to plug in what I know. In number 4, I'm given the short leg has a length of 9. So in the first equation, I'm going to replace the short leg with 9. So I have 9 radical 3 is equal to the long leg. And that is the length of the long leg. There's no way to simplify that. Okay. To find the hypotenuse, I take 2 times my short leg. So 2 times, replace the short leg with 9 as the hypotenuse. 2 times 9 is 18. So the length of my hypotenuse is 18. Okay, problem number 6. Again, I'm given a 30, 60, 90 degree triangle where my top angle is my 30 degree angle, so all the angles add up to 180 degrees. The side opposite the 30 degree angle is my short leg. The side opposite my 60 degree angle is the long leg. The side opposite the right angle is my hypotenuse. For a 30, 60, 90 degree triangle, I know that the short leg times radical 3 is equal to the long leg. And I know that 2 times my short leg is equal to the hypotenuse. Now, in this particular problem, I know the length of the hypotenuse. So I have to use the equation 2 times short leg equals the hypotenuse. And I'm going to replace the hypotenuse with 24. I'm going to solve for the short leg by dividing both sides by 2. Okay. So on the left side, I have the short leg equal to, on the right side, I take 24 divided by 2, and that is 12. So the length of my short leg is 12. Now, to find my long leg, I take my short leg times radical 3. So I just found my short leg to equal 12. So 12 times the square root of 3 is equal to the long leg. And that's my final length. There's no way to simplify that. So my long leg is 12 radical 3. The last problem I want to look at is problem number 8. Okay, in problem number 8, again, I have a 30, 60, 90 degree right triangle. The side opposite my 30 degree angle is my short leg. The side opposite my 60 degree angle is the long leg. The side opposite the right angle is the hypotenuse. Okay, so first I'm going to write down my equations. I know that my short leg times radical 3 is equal to the long leg. And I know that 2 times the short leg is equal to the hypotenuse. Okay. Now, this time I know the length of my long leg. So I have to use the first equation, and I'm going to replace the long leg with my length of 5. Okay, this is short leg times radical 3. So to solve for the short leg, I do the opposite of multiplication, which is division, and I divide both sides by the square root of 3. On the left side, the short leg remains. And on the right side, I have 5 divided by the square root of 3. Again, I cannot leave a square root in my denominator. So I have to go through a process called rationalizing the denominator. So I'm going to multiply the numerator and the denominator by the square root of 3. And I multiply straight across. 5 times square root of 3 is 5 radical 3. In the denominator, the square root of 3 times the square root of 3 is the square root of 9. I can take the square root of 9. Square root of 9 is 3. So I have 5 radical 3 divided by 3. This time I cannot divide 5 by 3. Therefore, 5 radical 3 divided by 3 is the final length of my short leg. to find the length of the hypotenuse, I take 2 times my short leg. So I take 2 times 5 radical 3 divided by 3. Now, if it's helpful to you, make your number 2 a fraction. To turn any number into a fraction, you put it over 1. And you multiply straight across. So 2 times 5 radical 3. 2 is not inside of a radical. 5 is not inside of a radical, so I can multiply those. And that becomes 10 square root 3. And in my denominator, I multiply 1 times 3, that's 3. So my hypotenuse is 10 radical 3 divided by 3. Again, I cannot divide 10 by 3 and get a nice number, so I'm going to keep this answer as a fraction. We are going to avoid decimals. Okay, I would like for you right now to try numbers 2, 5, 7, and 9, and on the next page, 10 through 15. You need to try these problems on your own. After you complete the problems, I want you to, in Canvas, under this page and modules, there will be an option to check your answers. So then I want you to go through and check your answers, and please shoot me an email if you have any specific questions. If you're having a lot of trouble, email me and I'll send you a Zoom link and we can talk for a few minutes via Zoom. Good luck.